Hello students, and welcome to today's lesson on real numbers. Our essential questions for today are, what are real numbers and what types of real numbers exist? With this second essential question, you will also need to sort numbers based on those types. Now I want to give you a very good depiction of real numbers. In this picture, you see my daughter Adelie and also her 3 cats. Here you see Adelie, Monster, Blackie, and Sprinkles. You see, my daughter, for as long as I can remember, has always played with these 3 cats. One day I said to her, "Wow, Blackie, he's such a really nice black cat." She said, "Mommy, he's not black, he's white." You know, I didn't know this because Blackie is an imaginary cat. And like imaginary friends, imaginary numbers exist as well. And they kind of have the same properties. If you think about the real cat, Monster, you would say that it is real because you're able to depict it. When I took the picture, it can be seen. On the other hand, the imaginary cats, Blackie and Sprinkles, they cannot be depicted in reality. They cannot be seen with the eye. The same is true with real numbers. Real numbers are the numbers that can be represented by our world's phenomena. In some way, you can show what the number is. You have been representing real numbers with the world for a very long time. When you ask for 2 cookies from your mommy and you put your 2 fingers up, you are depicting a real number, a number that could be shown. Now, there is one mathematical characteristic of all real numbers, and that is this one distinguishing factor. All real numbers, every single one of them, can be written as a decimal. Now, there are 2 major classifications of real numbers, which will be our focus in this lesson. We will not talk about imaginary numbers, but I do want you to know that they do exist, for you'll see them down the road in other courses. We are only going to focus on real numbers, the ones that can be seen. And we're going to look at 2 classifications. The first is rational numbers, and the second is irrational numbers. Now, both of these are examples of real numbers, and if you look at them, they both stem from the same word, rational. The only difference is this prefix "ear," and think about what the prefix "ear" means. Ear means not. So these are opposite words. Rational and irrational literally mean rational and not rational. Every real number will be one of these 2 types. Rational numbers have been your focus in mathematics study so far. Rational numbers are all the numbers that can be written as a fraction. Now, the distinguishing factor is its decimal. Every decimal of a fraction will either terminate, which means stop, or repeat. A terminating decimal is one that stops. An example would be 2.35782. It stops. It doesn't continue on and on and on and on forever. It ends with this digit here. A repeating decimal would be different. It would be something like 2.338. 338, and so on, 338, 338, a repeating decimal. It's always one of these 2 if it's a rational number. You can connect this to what you've already known. You have studied rational numbers and have learned some types. So let's let this box be all the real numbers. We just learned that there are rational numbers and there are irrational numbers. Most numbers are rational, and you have seen some of them. Integers. Integers are like -6 If you think about it, does its decimal repeat or terminate? Actually, both. It ends with the 6, but you could say it repeats as well. It repeats a 0, negative 6.0000, and so on. Any integer that you see is a rational number. Whole numbers are also rational numbers. Whole numbers, remember, start at 0. 0 is a rational number. You can see nothing. 1, 2, and so on. Those are all rational numbers. You could depict those. And also natural numbers, which are the set 1, 2, 3, and so on. It does fall within the whole number category. So you have seen some rational numbers. So to help you with irrational, think about being not rational. What are the opposites of those? Well, if rational means you can be written as a fraction, irrational means that you cannot be written as a fraction. And if rational means that you terminate, irrational means you do not terminate, meaning you do not stop. And is the opposite of or, and the opposite of repeating is to not repeat. So an irrational number does not stop and does not repeat. So if you typed it in your calculator screen, it would take up the whole screen and never have any sort of pattern to it. Now, it can be tricky to determine whether a number is rational or irrational, so I'm going to give you a list to help you decide whether they're rational or irrational. Let's start with rational, because if we can decide that it's not rational, we'll know that it's irrational. So, if you're trying to figure out if a number is rational or not, ask yourself, is it an integer? And if you say yes, then it's rational. So if I said negative 8, that's an integer, so it's rational. 2 is an integer, so that's a rational number. All integers are rational. Is it a fraction? And if you say yes, then it's rational. Every fraction is a rational number. Is it a decimal that repeats or terminates? So if I said 0.3333333, it repeats, so it's rational. If I said 2.5, that terminates, so it is rational. And last, which we'll talk about more in a minute, if it is a perfect square root, it will be a rational real number. All rational real numbers are one of these 4 qualifications. Now, the opposite, ask yourself, is it a non-perfect square root, which means it's not perfect, which we'll talk about in a minute, or is it a non-terminating, which means it does not stop and does not repeat, decimal, the opposite of this. Now, rational numbers said perfect square roots and irrational numbers said non-perfect square roots, so we need to look at some square root basics. A square root asks, what number multiplied by itself equals this number? So here's an example. This is your radical symbol. This is your square root sign. It says, what number multiplied by itself is 81? And if you think about that, what number times itself is 81? And it's the number 9. The square root of 81 is 9 because 9 times 9 is 81. The square root of 144. What number multiplied by itself is 144? 12. Now look at the numbers, 9 and 12. They are both integers, so we would say that those are perfect square roots. But what about the square root of 70? If you think about your square roots, you know that 8 times 8 is 64. So the square root of 64 is 8. We know that the square root of 81 is 9. There is no whole number in between, and the square root of 70 is in between, so it's going to have to be a decimal. It's somewhere between 8 and 9. So this is called a non-perfect square root. It does not equal a whole number. So what we just talked about was the square root of 81 and 144 are called perfect square roots because they equal a whole number. And the square root of 70 is a non-perfect square root because it does not, the symbol for does not equal a whole number. It's somewhere in between these two. Knowing this will help you determine whether it's rational or irrational, because remember, perfect square roots are rational and non-perfect square roots are irrational. If you know the first 12 perfect square roots, it can help you to figure out the non-perfect ones. I like to think about it as a clock. Here's the first 12 perfect square roots. The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16, and so forth. The square root of 25, the square root of 36, the square root of 49, the square root of 64, the square root of 81, the square root of 100, the square root of 121, oops, one too many ones, 121, and the square root of 144. Knowing this will help you with the non-perfect square roots. So if I said the square root of 50, is it perfect or non-perfect? It's not perfect because it's somewhere in between 7 and 8. So would this be rational or irrational? Irrational because it is not perfect. So knowing your perfect square roots can help you know whether it's an irrational or rational number. So here are some examples of rational numbers. 16 is a rational number because it's an integer. 1/2 is a rational number because it's a fraction. 3.56 is a rational number because it terminates, it stops. The square root of 16 is a rational number because it's a because it's a perfect square root. It equals 4. -8 is a rational number because it's an integer. 1.3333 is a rational number because it repeats. -3/4 is a rational number because it is a fraction. 1.25 with a bar over top is a rational number because this is a repetition bar, which means that it repeats. Here are some examples of irrational numbers. Any non-perfect square root, like the square root of 17, which would fall in between the square root of 16, which is 4, and the square root of 25, which is 5, is a non-perfect square root, so that means that it is irrational. Pi is also an irrational number. Just kidding. It is equal to 3.14159265 and so on, and it never repeats and it never stops. Watch part 2 of our lesson to see an example of a sorting activity.